Hello guys, welcome back to my YouTube channel. In today's video, we shall discuss about a mathematical topic which is a Latin square design. So Latin square design is a mathematical concept used in experimental design. It provides a systematic way to organize and analyze experiments involving multiple factors or treatments. The fundamental idea behind a Latin square is to create an arrangement of treatments in such a way that each treatment occurs exactly once in each row and each column of a two-dimensional array or the matrix. So the basic structure of a Latin square. A Latin square is typically represented as an n into n array where n is the number of levels or treatments being studied. Each row and each column of the Latin square contains all n treatments exactly once. The treatments are usually represented by symbols or numbers. Constructing a Latin square involves systematically arranging the treatments in rows and columns. Different methods such as randomization or specific algorithms can be used to create a Latin square. The construction process ensures that no treatment repeats in the same row or column, fulfilling the requirement of each treatment occurring exactly once in each row and each column. Properties. One of the key properties of the Latin squares is orthogonality. This means that the assignment of the treatments is done in such a way that it ensures that the effect of any one treatment is independent of the effect of any other treatment. Orthogonality is crucial for drawing valid conclusions about the individual effects of each factor. Balanced allocation. Latin square provides a balanced allocation of treatments. Each treatment appears the same number of times in both the rows and the columns. It minimizes the impact of confounding variables and ensuring an even distribution of treatment effects. Flexibility. They can be adapted for experiments with different number of factors or levels. They provide flexibility in experimental design while maintaining the key properties of orthogonality and balanced allocation. Randomization. It allows for a systematic but randomized arrangement of treatments. This randomization helps control for potential bias and ensures that each treatment is equally likely to occur in each position within the square. Efficiency. They are efficient experimental designs, especially when there are constraints on the number of experimental runs. They allow for a high degree of control and replication within a relatively small number of experimental units. Reduced confounding. By systematically arranging the treatments across the rows and the columns, Latin squares help reduce the likelihood of confounding, which occurs when the effect of one factors are mixed with the effects of another. This is particularly valuable in isolating and identifying the individual effects of different factors. Ease of analysis. The structured name of Latin squares simplifies the analysis of experimental results. Statistical analysis can be performed more efficiently due to the controlled and systematic arrangement of treatments. Versatility. Latin squares find applications in various fields, including agriculture, medicine, industry, and the more. Their versatility makes them so suitable for a wide range of experimental settings where controlled and balanced designs are necessary. Applicability to partial designs. Latin squares can be extended to partial Latin squares, which are useful when not all the combination of the factors are feasible or practical to test. This allows researchers to conduct experiments in a more resource efficient manner. And another property is minimization of external variation. Latin squares help minimize the impact of external or uncontrollable variations by ensuring that each treatment is exposed to a similar range of conditions and making the experimental results more reliable. So let us have a look on the example of a Latin square design. Let us consider a 3 into 3, that is a matrix, and it is representing an experiment with three treatments, which is A, B, C. Here A, B, C is there, again the BCA and CAB. In this Latin square, each treatment appears exactly once in each row and each column, satisfying the properties of both orthogonality and the balanced allocation. So, in summary, Latin square design is a valuable tool in experimental mathematics and providing a structured approach to designing experiments, and it analyzes the effects of multiple factors while minimizing bias and confounding variables. So, what are the applications? The very first application is the agriculture experiments. Let us assume a scenario where the testing the impact of the different fertilizers on the crop yield. So, Latin squares, it helps to allocate different fertilizers across different plots, and it is ensuring that each fertilizer is tested in various field conditions. Next is the clinical trials. The scenario here again, it is investigating the effectiveness of different drug treatments for a specific medical condition. Again, the Latin square assists in randomizing the administration of drugs to the patients, ensuring each treatment is equally distributed and minimizing the influence of a patient variability. Education testing. Here the scenario is designing exams with multiple versions to prevent cheating. Even here, the Latin squares help create exam versions where each question or topic is equally distributed, and then it is minimizing the risk of cheating while maintaining the fairness. Next is the industrial quality control. Here the scenario is it testing the impact of different manufacturing processes on the product quality. And again the application here is Latin squares, it assists in allocating different production methods to ensure each method is tested under various conditions, and it is helping identify the most effective process. Next, it is used in computer science and cryptography. The designing the experiments to evaluate the efficiency of different algorithms or cryptographic protocols. Here also the Latin squares assist in the systematic allocation of algorithms or protocols to experimental conditions and ensuring a fair comparison. It is even used in textile industry. The scenario is testing the impact of different dyeing processes on fabric quality. Application: Latin squares help allocate different dyeing processes to experimental runs, allowing for a comprehensive evaluation of each process. Thank you guys. Stay tuned for more such videos. Please do like, share and subscribe.